1-5 Quadratic Equations, Day 3. Your learning goal is that you will be able to write functions in equivalent forms and graph functions with and without technology. In this lesson, we're going to review the quadratic formula. I have a song, pardon my voice because I'm still a little hoarse, that'll help you remember the quadratic formula. X equals negative b plus or minus square root b squared minus 4ac all over 2a. So that song will help you remember it because it has to be memorized. And then the portion that's under the square root, the b squared minus 4ac, is called the discriminant, and it tells you the number of solutions and the type. For example, and it's without the square root now, so it's b squared minus 4ac is positive. Then you have two unequal real solutions, which means if you graphed it, it would have two x-intercepts. If your discriminant equals 0, then you have one real repeated solution, because remember, quadratic means 2. And if you graphed it, it would have one x-intercept. And if your discriminant is negative, it's less than 0, it has no real solutions, which means it's two imaginary solutions, which means it has no x-intercepts. So it's either going to have 2, 1, or 0 x-intercepts. Okay, example 1a, we're going to solve the equation using the quadratic formula. The first thing you want to make sure is your equation equals 0. And let's make sure that the leading coefficient is positive so that we all get the same answer. And then you just apply the formula, identifying a. So in the equation, it should be in the form ax squared plus bx plus c equals 0. That's a quadratic equation, which means a would be 2, b is negative 6, and c is 1. Then all you have to do is plug everything in the formula. X equals negative b, but b is already negative, plus or minus square root. Now watch this. When I do b squared, you need to put it in parentheses. Minus 4ac all over 2a. And from here, you just simplify. And you're going to get 36 minus 8, which will give us 28. And then if you can, you want to break down 28, which will be the square root of 4 times the square root of 7. So that'll leave you with 6 plus or minus 2 square root of 7. And then if you can, you want to find a number that will divide into each of these evenly. And that'll be 2. So I'm going to divide each term by 2. So that'll leave me with 3 plus or minus 1 radical 7 all over 2. Example 1b. First you identify a, b, and c. So a is 9, b is negative 6, and c is 1. Then you apply the formula. X equals negative b, but b is already negative, so it becomes positive. Make sure you put b squared in parentheses. Minus 4ac all over 2a. And then you simplify what's under the radical. You're going to get 36 minus 36, which is 0, over 18. Square root of 0 is 0. This is 6 over 18, which equals 1/3. So that's one real repeated solution. And then C, A is 3, B is -8, and C is 7. Apply the formula. B is negative again, so it becomes positive. Make sure you put b squared in parentheses, all over 2a. Then you simplify what's under the radical. You're going to end up with 64 minus 84, which is -20, over 6. And you know you can't leave this negative. So -20 breaks down to square root of -4 times the square root of 5. I usually put the negative with the perfect square. So that's going to leave you with square root of -4 is 2i. Radical 5 over 6. Then you find something that divides into 8, 2, and 6 evenly, which is 2. And you also have to make sure you write it in standard form when you end up with a imaginary solution. That means you split it up. So it's 8 over 6 plus or minus 2i, radical 5 over 6. And then you reduce it, 4/3 plus or minus I, radical 5 over 3. And that is your solution. Okay, example 2, we're going to compute the discriminant, then determine the number and types of solutions. So for A, we have 3x squared plus 4x minus 5 equals 0. A is 3, B is 4, C is -5. Remember my discriminant formula is b squared minus 4ac. So I'm doing 4 squared minus 4ac. So I'm going to end up with 16 plus 60, which equals 76. So since it came out to be positive, and it's not a perfect square, then that means that there are 2 irrational solutions. It's irrational because it's not a perfect square. Okay, B, 9x squared minus 6x plus 1 equals 0. A is 9, B is -6, and C is 1. So applying the formula, b squared minus 4ac. So I get 36 minus 36, which equals 0. So because it equals 0, then it's one real solution. And then C, 3x squared minus 8x plus 7. A is 3, B is -8, C is 7. That's supposed to be equal 0. Applying the formula, we're going to do b squared minus 4ac. So that's 64 minus 84 equals -20. Because it is negative, then there are two imaginary solutions. Now that we've gone over the different methods to solve quadratic equations, factoring, completing the square, square root property, and quadratic formula, some people may need to know, when should I use which method? Well, you would factor and use the zero product rule if it's in this form, ax squared plus bx plus c, and it was easy to factor. You definitely want to use this method. Or it's in this form where there's no constant term. You can use GCF, find the greatest common factor, and then use the zero product rule. You would solve for x squared and use the square root property if it had no middle term. So you'll get the x squared by itself and then use the square root property. And you can also use the square root property if it's in this form. And then the quadratic formula is best used when you have a trinomial quadratic. Oh, and this one equals 0, just to remind you. And it can't be factored. So when you have the choice, then these are helpful to decide which method you should use. Completing the square is only helpful if you like that method or they ask you to.